Chapter 8, Part 4 of Airplane Flying Handbook, Volume 1. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Andrea Kay. Airplane Flying Handbook, Volume 1 by Federal Aviation Administration. Chapter 8, Part 4. Short Field Approach and Landing. Short field approaches and landings require the use of procedures for approaches and landings at fields with a relatively short landing area or where an approach is made over obstacles that limit the available landing area. Figures 8-20 and 8-21. As in short field takeoffs, it is one of the most critical of the maximum performance operations. It requires that the pilot fly the airplane at one of its crucial performance capabilities while close to the ground in order to safely land within confined areas. This low-speed type of power-on approach is closely related to the performance of flight at minimum controllable airspeeds. To land within a short field or a confined area, the pilot must have precise, positive control of the rate of descent and airspeed to produce an approach that will clear any obstacles, result in little or no floating during the roundout, and permit the airplane to be stopped in the shortest possible distance. The procedures for landing in a short field or for landing approaches over obstacles, as recommended in the AFM-POH, should be used. A stabilized approach is essential. Figures 8-22 and 8-23. These procedures generally involve the use of full flaps and the final approach started from an altitude of at least 500 feet higher than the touchdown area. A wider than normal pattern should be used so that the airplane can be properly configured and trimmed. In the absence of the manufacturer's recommended approach speed, a speed of not more than 1.3 VSO should be used. For example, in an airplane that stalls at 60 knots with power off and flaps and landing gear extended, the approach speed should not be higher than 78 knots. In gusty air, no more than 1/2 the gust factor should be added. An excessive amount of airspeed could result in a touchdown too far from the runway threshold or an after-landing roll that exceeds the available landing area. After the landing gear and full flaps have been extended, the pilot should simultaneously adjust the power and the pitch attitude to establish and maintain the proper descent angle and airspeed. A coordinated combination of both pitch and power adjustments is required. When this is done properly, very little change in the airplane's pitch attitude and power setting is necessary to make corrections in the angle of descent and airspeed. The short field approach and landing is in reality an accuracy approach to a spot landing. The procedures previously outlined in the section on the stabilized approach concept should be used. If it appears that the obstacle clearance is excessive and touchdown will occur well beyond the desired spot, leaving insufficient room to stop, power may be reduced while lowering the pitch attitude to steepen the descent path and increase the rate of descent. If it appears that the descent angle will not ensure safe clearance of obstacles, power should be increased while simultaneously raising the pitch attitude to shallow the descent path and decrease the rate of descent. Care must be taken to avoid an excessively low airspeed. If the speed is allowed to become too slow, an increase in pitch and application of full power may only result in a further rate of descent. This occurs when the angle of attack is so great and creating so much drag that the maximum available power is insufficient to overcome it. This is generally referred to as operating in the region of reversed command or operating on the backside of the power curve. Because the final approach over obstacles is made at a relatively steep approach angle and close to the airplane's stalling speed, the initiation of the roundout or flare must be judged accurately to avoid flying into the ground or stalling prematurely and sinking rapidly. A lack of floating during the flare with sufficient control to touch down properly is one verification that the approach speed was correct. Touchdown should occur at the minimum controllable airspeed with the airplane in approximately the pitch attitude that will result in a power-off stall when the throttle is closed. Care must be exercised to avoid closing the throttle too rapidly before the pilot is ready for touchdown, as closing the throttle may result in an immediate increase in the rate of descent and a hard landing. Upon touchdown, the airplane should be held in this positive pitch attitude as long as the elevators remain effective. This will provide aerodynamic braking to assist in deceleration. Immediately upon touchdown and closing the throttle, appropriate braking should be applied to minimize the after-landing roll. The airplane should be stopped within the shortest possible distance consistent with safety and controllability. If the proper approach speed has been maintained, resulting in minimum float during the roundout, and the touchdown made at minimum control speed, minimum braking will be required. Common errors in the performance of short-field approaches and landings are failure to allow enough room on final to set up the approach, necessitating an overly steep approach and high sink rate, unstabilized approach, undue delay in initiating glide path corrections, too low an airspeed on final resulting in inability to flare properly and landing hard, too high an airspeed resulting in floating on roundout, prematurely reducing power to idle on roundout resulting in hard landing, touchdown with excessive airspeed, excessive and/or unnecessary braking after touchdown, failure to maintain directional control. Soft field approach and landing. Landing on fields that are rough or have soft surfaces, such as snow, sand, mud, or tall grass, requires unique procedures. When landing on such surfaces, the objective is to touch down as smoothly as possible and at the slowest possible landing speed. The pilot must control the airplane in a manner that the wings support the weight of the airplane as long as practical to minimize drag and stresses imposed on the landing gear by the rough or soft surface. The approach for the soft field landing is similar to the normal approach used for operating into long, firm landing areas. The major difference between the two is that during the soft field landing, the airplane is held 1 to 2 feet off the surface in ground effect as long as possible. This permits a more gradual dissipation of forward speed to allow the wheels to touch down gently at minimum speed. This technique minimizes the nose-over forces that suddenly affect the airplane at the moment of touchdown. Power can be used throughout the level off and touchdown to ensure touchdown at the slowest possible airspeed, and the airplane should be flown onto the ground with the weight fully supported by the wings. Figure 8-24. The use of flaps during soft field landings will aid in touching down at minimum speed and is recommended whenever practical. In low-wing airplanes, the flaps may suffer damage from mud, stones, or slush thrown up by the wheels. If flaps are used, it is generally inadvisable to retract them during the after-landing roll, because the need for flap retraction is usually less important than the need for total concentration on maintaining full control of the airplane. The final approach airspeed used for short field landings is equally appropriate to soft field landings. The use of higher approach speeds may result in excessive float and ground effect, and floating makes a smooth, controlled touchdown even more difficult. There is, however, no reason for a steep angle of descent unless obstacles are present in the approach path. Touchdown on a soft or rough field should be made at the lowest possible airspeed with the airplane in a nose-high pitch attitude. In nose-wheel-type airplanes, after the main wheels touch the surface, the pilot should hold sufficient back elevator pressure to keep the nose wheel off the surface. Using back elevator pressure and engine power, the pilot can control the rate at which the weight of the airplane is transferred from the wings to the wheels. Field conditions may warrant that the pilot maintain a flight condition in which the main wheels are just touching the surface, but the weight of the airplane is still being supported by the wings until a suitable taxi surface is reached. At any time during this transition phase, before the weight of the airplane is being supported by the wheels and before the nose wheel is on the surface, the pilot should be able to apply full power and perform a safe takeoff, obstacle clearance and field length permitting, should the pilot elect to abandon the landing. Once committed to a landing, the pilot should gently lower the nose wheel to the surface. A slight addition of power usually will aid in easing the nose wheel down. The use of brakes on a soft field is not needed and should be avoided, as this may tend to impose a heavy load on the nose gear due to premature or hard contact with the landing surface, causing the nose wheel to dig in. The soft or rough surface itself will provide sufficient reduction in the airplane's forward speed. Often it will be found that upon landing on a very soft field, the pilot will need to increase power to keep the airplane moving and from becoming stuck in the soft surface. Common errors in the performance of soft field approaches and landings are excessive descent rate on final approach, excessive airspeed on final approach, unstabilized approach, round out too high above the runway surface, poor power management during round out and touchdown, hard touchdown, inadequate control of the airplane weight transfer from wings to wheels after touchdown, allowing the nose wheel to fall to the runway after touchdown rather than controlling its descent. End of Chapter 8, Part 4. Recording by Andrea K.